All right, let's get into it. Today we're going to pull back the curtain on one of the most fundamental yet kind of mysterious technologies of the internet, the system that actually discovers and maps the entire World Wide Web.
I mean, really think about it. You type something into a search bar and bam, in less than a second, you get results from pages you have never, ever heard of. How in the world does a search engine even know those pages exist in the first place?
Well, the answer is this unsung hero, the web crawler. The best way to think of it is as a digital explorer, an automated little robot that is tirelessly charting the vast, chaotic, and ever-changing territory of the web, all so we can find what we're looking for.
But this explorer isn't just taking a casual stroll through a park. Oh no, it is facing what we can call the billion-page problem. And the scale of this task, it's almost impossible to wrap your head around.
So let's just try to put some numbers on this. To stay even remotely relevant, a major search engine's crawler needs to find and collect about 1 billion new or updated web pages every single month.
So to even have a chance at hitting that ridiculous target, it has to be unbelievably fast. We're talking about downloading around 400 pages every single second, 24/7, non-stop. And of course, all of that data has to go somewhere, right? That's 500 terabytes of storage needed each month. And if you hang on to that data for 5 years, which a lot of services do, you are looking at 30 petabytes. I mean, that is a truly massive engineering challenge. So to tackle a problem of this magnitude, any crawler worth its salt absolutely needs these 4 qualities. It has to be scalable to handle the web's sheer size. It's got to be robust enough to deal with all sorts of errors and traps. It has to be polite, and we'll get into why that's so important, and it has to be extensible so it can adapt to whatever the internet throws at it next. So how do you actually build something like this? Let's pop the hood on our digital explorer and break down its anatomy into the key components.
First up is the URL frontier. Now, it's a powerful concept, but it's pretty simple to understand. Just think of it as the crawler's to-do list. It's the list that holds all the URLs that are just waiting to be visited.
Next, you've got the HTML downloader. This is the workhorse of the entire system. Its whole job, its entire reason for being, is to take a URL from that to-do list and just go fetch the page from the internet.
So once a page is downloaded, it gets handed off to the parser and extractor. You can think of this part as the quality control inspector. It checks the page to make sure it's valid, and then it does its most important job. It meticulously finds all the new links on that page to explore later.
And finally, we have the system's memory. A crawler has to be constantly asking 2 really important questions. Have I seen this URL before, and have I seen this exact content before? This is what prevents it from getting stuck in endless loops or just wasting tons of resources. And it's crucial because, get this, about 29% of the web is just duplicate content.
Okay, so we've got the parts. Let's move over to the assembly line and see how this all works together. We're going to follow one single URL as it makes its journey through the whole system.
So it all kicks off with a seed URL. It's sitting there on the Frontier's to-do list. The downloader grabs it, uses the DNS resolver to figure out its real-world address on the internet, and then pulls down the page. Finally, the parser gives it a quick quality check just to make sure the code is valid.
And here is where the magic happens, the feedback loop. The system checks if it's seen the content before. If the page is brand new, the extractor pulls out every single link. It checks if those links are new, and then it adds them right back to the Frontier's to-do list. It's this perfect, self-sustaining cycle of discovery.
But, just scrolling endlessly isn't really enough. The real magic, the secret sauce that makes this whole thing work, is in crawling smarter, not just harder.
So how should a crawler explore? It really has 2 main strategies. There's the deep dive, where it goes way down one rabbit hole at a time. The problem is it can get stuck. Then there's the wide sweep, where it explores all the nearby links first. To discover the sheer breadth of the internet, crawlers pretty much always prefer the wide sweep.
But there's a big problem with that simple wide sweep. Imagine a website's homepage has, say, 1,000 links all pointing to other pages on its own site. A naive crawler would try to download all of them at once. And in the world of the internet, that's considered very, very rude. And by rude, I mean it can be potentially harmful. The source material is super clear on this. Sending too many requests at once can actually be treated as a denial of service attack. You just can't have your crawler accidentally taking down the very websites it's trying to index. That's a huge no-no.
This is where the URL frontier becomes way more than just a simple to-do list.
It starts acting like air traffic control for the web. It intelligently groups all the URLs by website, making sure it only sends one request at a time to any single server. It also prioritizes more important pages, like a home page, over less important ones, like some obscure post on a forum.
And believe me, crawlers are constantly navigating a minefield of problems. Just look at this breakdown of the challenges. Nearly a third of the entire problem is just dealing with duplicate pages. And right behind that are spider traps. These are tricky parts of websites, sometimes designed on purpose to trap a poor little crawler in an infinite loop forever.
So to navigate all of this safely and politely, a well-behaved crawler always makes a first stop. Before it even thinks about downloading a single page from a site, it checks a simple text file called robots.txt. This is basically a public set of rules, a welcome mat, that the website owner puts out, telling the crawler exactly what it is and isn't allowed to look at.
So, what's the big takeaway here? A web crawler is this beautifully complex system that's designed to solve the immense challenge of mapping the internet. It's this elegant loop of specialized parts. And the smart part isn't just about raw speed. It's about being polite, prioritizing work, and avoiding traps. It is, without a doubt, the foundational technology that makes modern search even possible.
And that brings us to one last, really fascinating thought for the future. We've just seen how crawlers map a web that was built mostly by humans. But as the internet fills up more and more with AI-generated text and images, how will the next generation of these digital explorers ever be able to tell the difference between what's real and what's not?